Well, as you remember, I was suggesting that we now continue with the presentations. There's another 3, and then without interruption, we continue with the roundtable discussion, which essentially means an open discussion. So although I will ask some of the speakers to sit around this table, then all of the others will also be sitting around it in one way or another, and people can come and ask or answer questions from here. I would like to introduce the next speaker, Paula Kadima. She trained as an architect in Lisbon, where she teaches at the Faculty of Architecture, where she also runs a master's program in sustainable design. Well, Paula is very familiar with the AA because she studied with us for several years for her PhD, and then worked with me on research projects for several more years. In Lisbon, in addition to the teaching, she also runs her research and architectural consultancy called Urban Aerodynamics. Paula.
With belonging to the list to the end is that almost everything was said already. So I hope I'm going to be able to bring some new things, or maybe there are some new people in the room. Well, my presentation is basically organized in 2 parts. The first part will just make a summary, introduction to the problem, and towards the end I will present 2 examples from recent examples from Portugal, using new technologies into the facades. So, similar to clothing, the skin protects the interior of the environment, protecting it from the outdoor conditions. So, being a transitional element, it protects from wind, it gives thermal insulation, and it also protects from direct radiation. If transparent, the element between the indoor and the outdoor can allow for natural lighting. If openable, it can allow for natural ventilation, and it also can provide nice views towards the outside. Environmental design use materials and elements to improve interior comfort in terms of visual, thermal, acoustic, and quality of air, provide views and access to the outdoor environment, and reduce energy use too. Much have been said about glazed skins. I'm showing here an opaque skin, a non-transparent skin. In fact, the skins of a building can transform the interior climate, but they can also transform the surrounding climate. It has been recently reported that the Walt Disney Concert Hall in Los Angeles, designed by Gary and recently accomplished, has now to undergo a refurbishment. And the reason of this is because these shiny and polished stainless steel surfaces are emitting so much heat that some areas reach up to 60 degrees centigrade. And well, this is enough to melt plastic or to burn the skin of pedestrian. Also, it provokes glare to nearby drivers. And some neighbors complain that their bills for air conditioning has duplicated since the summer, since the building was erected. And others say that they no longer can use their terraces. So Gary already agreed with a refurbishment. They are going to brush over 1,000 square meters of these surfaces, and maybe this will change some of the impact. Let's see. Glazed materials or glazed facades have been used for for some ages already. In the beginning, the single-glazed buildings brought some problems to the interior, in particular because some overheating problems and some high consumption during the winter. So the double glazed, well, since the developments of the glazings into double glazing, structural glazing, and also selective glazing has allowed for new possibilities and also increased comfort and energy savings. A very hot topic today is the double skin glazed facade. And there are many examples claiming to be low energy efficient using this type of solution. The top image is a building in Brussels, and the two lower ones are two different types of buildings in Lisbon. One corresponding to an office building and the other one to a hotel. Maybe you don't guess which it is which. Okay. So I'm not going into much detail about the different kinds of double skin facades, maybe you already know. But there are several combinations, and they can be classified according to different parameters, which is the destination and the origin of the air, if it comes from the outside or from the inside, and also depending on the ventilation type, which can be natural, it can be mechanic or hybrid. But basically what it does is there are two facades with a gap inside, and this creates a space which is like a thermal buffer space, and this is intended to reduce heat losses in the winter, and also to protect, also to reduce heat gains. Of course, if you use solar control elements and some ventilation systems, this can be the comfort can be improved inside the buildings. Well, this is another icon building. I'm sure you already know, all of you. So it's the refurbishment of the European Commission headquarters, the Le Mans building. And this refurbishment has used this type of solution with this second surface, which is consisted on movable louvers. And they also claim that this is a low energy solution, which protects also from acoustic problems, providing views to the users, and also works as a high-tech blanket, keeping warmth inside the building in the winter, and also protecting the inner skin from direct radiation. All right, so what I'm worried, and as a teacher, I'm also worried about all these images and all these solutions that my students and architects get from magazines, from internet, from all over, and they think, oh, that's a good solution, let's apply it. And so it has been already here said the importance of the context, and I'm just showing one example in Lisbon, but we have many similar examples. This is an office building in Saldanha, in the center of Lisbon. It was designed by the Spanish architect Bofill, together with the Portuguese architect Paciência. And it uses this double skin glazed facade. One of my master students is doing some monitoring of this building. I have no results to show you, but he has already interviewed the occupants of the building. As you can see on the plan, all these facades are exactly the same. They don't change according to the orientation. And particularly the southeast and southwest facing facades, the occupants sitting there complain a lot about heat and about glare, etc. But also the owner of the building complains about the bills he has to pay, because instead of doing something or decreasing the energy consumption, it's even worsening the case. So it also complains to be sustainable. Okay, so let's a little bit see our situation in the whole Europe. As you see, Portugal we have an advantage in terms of radiation we have. And so also another plan, which means which shows the total hours per year that we can have on the whole country. And now it's a question mark. It's open for some questions, which is it that we should say no, we shouldn't use new technology facades into the buildings, and it has already here been discussed. Thanos also told about this. It's true that students always want to use this innovation image and the glazed facade and so on. So what shall we do shall I say, no, you don't do it? I mean, of course you can do, but you have to know the impact of the solution you are designing to the specific site of the building. So now I'm going to show the two examples. This is a road traffic control center in Carcavelos. Carcavelos is very close to Lisbon, is off the highway between Lisbon and Cascais, if some of you know the place. It was designed by the architect João Carrilho da Graça with Barbini and Silva, and the energy concept by Natural Works engineering consultants. And this glazed facade, these are solar panels, and the whole building, all the facades, but not the north facade, also the roof, have these solar panels, not only to heat the building, but also to cool the building. We can see the roof. So the roof is composed by several solar panels with a tilt of 7 degrees. No more inclination was allowed due to architectural constrictions. The architects didn't want the panels to be seen from the outside. And also something particular I wanted to add here is that these panels were specifically designed for this project because the architect didn't like the previous framing on each panel. So it was redesigned to make the framing a bit shorter to have a more glazed impact. Seamus, you tell me about the time, okay? So the building design brief demanded for a full closed building skin attaining an undisturbed environment in the large 400 square meter road traffic control room. So it's really in front of the highway. The harsh acoustic environment from an adjacent high traffic road pushed the building openings towards the north, freeing the remaining facade orientations. And in this scenario, the design team searched for alternative uses for a building skin freed from the demand of ensuring natural light and air penetration. So this search resulted in a large solar thermal energy collecting surfaces being installed in the facade and using the local climate's high solar availability. These surfaces perform several tasks such as thermal energy collection for cooling and heating system, shading of the building external skin, and improvement of the acoustic insulation. Also, the cooling potential of the solar collecting surfaces was used by installing a single effect absorption cooling chiller. So these are also some simulations done during the design. I'm okay with the time. Simos? Okay, so I still need to show. This is also an interior image from the controller room, where the simulation the monitoring already showed, because this building is being monitored, that stratification levels in the hall reach a difference of 10 degrees. And this is the second building I wanted to show you tonight, or this afternoon. Which is, this is a service building, offices and labs. It was designed by the young architect Pedro Cabrito. He's also teaching in my faculty with Isabel Diniz. And the energy systems, efficiency system was designed by Helder Gonçalves from the INETI. Actually, this building is on the site of INETI. INETI is the Institute of National Energy Technology and Innovation, and they are going to monitor this building. It's still under construction. It's going to be finished maybe next month. So I was not able to get an image of this facade with the panels. These are PV panels, but I can show some recent images. So the plan, as you can see, the rooms which are most used are all facing south. And the labs and the meeting rooms are towards the north side of the building. And in front, it has all these PV collectors for providing electricity for lighting. And also, there is a system which will use thermal recovery to heat the building. It's divided into 3 different levels. And also, I have another image. There was some care on the natural lighting of the building through the core of the building. And also the design allows for natural cross ventilation. Another innovative or another experience in this building is the use of the underground cooling system, which are buried pipes of around 30 centimeters diameter. They are digged down to 4.5 meters and with a path of 15 meters more or less. Well, just to give you some values, the outdoor temperature in the summer can achieve 30 to 30 degrees Celsius, and the air coming through these tubes will come out around 14 to 18 degrees Celsius. And so this system will allow to cool the rooms. As we can see in the picture, each room has 2 ducts, which can be controlled by the user. And about the PV thermal strategy, what happens? It has 3 different modes. In winter, it recovers the heat through openings on the bottom and on the top. In the summer, it allows the air to go out through stack effect. And in the mid-season, it has a system which allows the preheating through natural convection. So, well, my conclusions go very much along what Brian said, and Brian said this much more thoroughly than what I'm summarizing here, but just to make a very brief summary. So, it's very important understanding the physical principles. It's also important the use of assessment tools as well as their interpretation. Report on monitored case studies, good and bad, and show good practices examples. Also, the relationship to climatic conditions, contextual, is of major importance. Thank you very much.
Thank you, Paola. Well, the next speaker is also an AA graduate and contemporary of Susan Rose, and a student, ex-student of that famous Rational Technology Unit. He was their wind energy specialist, Dr. Derek Taylor. He then went on to do a PhD in wind engineering, and since then is the inventor and patent holder of umpteen different designs of wind engines and other devices. I'm sure he'll tell us about it. He runs his own company, All Technica, based in Milton Keynes, and is also a lecturer at Open University. Derek.
Thank you so much. Okay. Let me do this. Okay. We can obviously design buildings to take account of energy efficiency to get our energy demand right down on the thermal side, but we're still left with how we deal with hot water and electricity. And this is where I think we can start to think about incorporating renewable energy technologies into the actual design of the building. Can help to address those issues. The actual renewable energy resources are actually very large. Most of them are derived from solar energy, and there's about 10,000 times amount of energy coming from the sun compared to what we currently use in conventional energy. Obviously solar energy it's usually not considered that important in the UK, but there's been a DTI study indicating that if we used all the available roof area for generating electricity, that would be comparable to our current electricity demand. Wind energy is most dominant in the UK. Hydro energy is site specific, but it can be appropriate. Biofuels is another whole wide spectrum of technologies, primarily different kinds of fuels similar to what we're currently using. Geothermal and ground source energy, also quite well distributed. And we also have tidal and wave energy in the UK. Renewable energy sources can provide a whole variety of end uses, including electricity, mechanical power, heat, and we can actually generate fuels from a wide variety of the renewables, not just the biofuels. It can be used in buildings in several ways. It can be extracted elsewhere and transported in the conventional way, or we can actually think about designing the building and its environments to actually maximize the use of that renewable energy interacting with the building. We're already using it today. What we want to do is try and make use of it more efficiently. That's by using the active collectors. So the collectors themselves are how we actually capture energy or design the building itself as the solar collector and as passive solar heating, or daylighting, or using the sun to drive ventilation and cooling. And solar energy can seriously help to reduce our CO2 emissions. Active solar primarily consists of a collector. In the UK, the two main types is a flat plate collector, where it's similar to a central heating and radiator panel, which is the glazed front, side, and insulated rear. Or we have evacuated tubes, which are derived from fluorescent tube technology, and they will give higher performance, and they can be used in slightly different ways. There was a lot of interest in active solar space heating a while ago, in the 70s and 80s, but we tend to forget about the insulation word, and so these systems tend to be sized very large, whereas if we start to look at them again today, there may well be scope to actually supplement space heating with solar energy. And these are a couple of examples of how that might go ahead. The ones in Milton Keynes was operated by Bob Everett, who's at the back of the house there. Air collectors are another interesting approach, where you don't have all the problems of leakage and corrosion you do with water, and you can afford to make the whole of a wall or a roof area simplified, maybe not as efficient, but you can make use of that energy either for cooling or for hot water or for passive heating as well. And it also can enhance passive solar performance. But we can also design the fabric itself and the roof, so it's actually the collector, it's the insulator, it's the structure, and then you start to make inroads into the cost effectiveness, and by also taking account of interseasonal abilities of storage. When you like larger scale, it tends to make a bit more sense. And you can then store the energy from the summertime and then reuse it in the wintertime. And combining that with district heating systems also helps to improve the viability. And by introducing a big heat store, you can actually give better security of supply. The Pimlico heat accumulator has been operating for tens of years, and that gives them quite a few days of security supply of heating. But as well as using solar energy for heat and cooling, etc., it also has the ability to generate electricity, and the limitations are really just down to what we want to use them for. There's laminates, there's roof tiles, there's metal roofing systems, there's semi-transparent modules, there's tinted glazing, there's north lights on the south side of those, there's solar shading devices. So, PV tends to be an expensive source, but if you can actually do several different jobs, then it starts to become more viable. And it still is a better investment than a motor car or a kitchen, because you get a return, even though most people think the payback in PV is not that great. But if you can actually make it do several things like shade the building and also substitute for an expensive cladding material or help to reduce the air conditioning load, then it starts to make a bit more sense. But it does mean you have to take about the design and not a bolt-on technology. You can also do it on a larger scale. This is a megawatt distributed power system in Amsterdam, where they looked at a whole variety of different approaches, and including the power company renting the roof of the householders so that they didn't have to find the capital investment. So that's another way around the difficulty of developing these technologies. Or you can include it as a part of a big envelope. This is another 1 megawatt PV array in Germany, which has a sort of sheltered environment, and is reckoned to get a 23% energy saving and 80% reduction in CO2. Okay. Anybody knows? I'll have to talk about wind energy. It is the most important technology in the UK, after all. Currently, the estimated wind resource on land, excluding any environmentally sensitive sites, is comparable to our current electricity demand. And if you go offshore, then it's even bigger. And UK's got 40% of the UK wind resource. And the technologies have been improving somewhat, so that sites which wouldn't have been feasible just a few years ago are now becoming practical. So you had to have 7 meters per second annual mean wind speed to consider a site practically feasible. Now you can do it 6.5 meters per second, and some people can do it for 6. The range of technologies for wind turbines range from very small micro turbines, which produce a few watts, and primarily developed for boats and caravans and the like. And they're very inexpensive, but they don't produce a great deal. Then you have the small scale range, and then you go up to really large multi-megawatt machines. The latest size in the market is 4.5 megawatts, and I think a 5 megawatt machine is now available. And interesting to note that one of those turbines would actually generate more electricity than the first UK wind farm in Cornwall of 10 turbines. So it's quite a big change. And also they're getting higher, so you can capture higher wind speeds. These are the micro turbines and the small scale turbines. These tend to be the more expensive in terms of per kilowatt, because of the cost of the tower and the foundations tends to be a higher proportion of the cost compared to the larger machines. The power that the turbine produces is proportional to the wind speed, and very roughly it's the cube of the wind speed gives you a relationship with the power. So you have this sort of sharp curve, and every wind turbine has that kind of characteristic, but they have different types of maximum wind power outputs. So you can't really compare one with another unless you look at those curves. But there are all kinds of visions for how small-scale wind turbines might be introduced into the built environment. One of the problems with small turbines is their higher cost per kilowatt. So it might make sense to have a community wind turbine which is shared amongst a group of buildings, and this certainly economically and technically is certainly becoming much more feasible. Turbines of this sort of size are ranging from about 600 to £1,000 a kilowatt. To date, it hasn't really made a lot of sense to consider wind energy in the urban environment because it's usually been a bit rough terrain. But if you have an open site and with the improved performance of wind turbines, then these sorts of situations can make sense, particularly if you're offsetting retail price electricity, which in many cases some of the sites are. Oh, we seem to be jumping around a bit here. Okay. So what we can do to improve the energy in the urban environment is to use higher turbines, but also to actually increase the wind speed, because as we said, there's a cubic relationship between wind speed and power. If you just increase the wind speed by a quarter, you've actually doubled the power. So one of the things we've been looking at is how you can actually design buildings to actually achieve that function. And this is one of the examples that we've been looking at, the alien roof, where we actually shaped the roof so it's more streamlined than perhaps it would be normally. And so it's taking more of a Formula One racing car approach. And that enables us to increase the wind speed over the ridge of the building. And it looks like we're actually pulling wind speed from a higher level down. So it's actually like a tall tower. Initially, we thought curve-shaped buildings was going to be the way to go, and that certainly will give you the best performance, but it does look as though pitched roof buildings will still give us quite a serious amount of augmentation. And the test building on the right is what we're just about to carry out our testing program to complete for a few small turbines in that slot. We just took delivery of the wing for that this week, so that should be very interesting. It looks like, from our computer fluid dynamic analyses, which we've validated against full-scale measurements over a building, that we might be getting maybe a 50% increase in wind velocity through that slot. Whether we can actually exploit all of that as energy remains to be seen, but that is the aim. The other variation of this is the alien tower. We're actually using the corner of the building to do the same thing as the ridge. And then you're getting into much higher wind speeds. Even in London, I have heard that people are actually measuring annual mean wind speeds of over 7, maybe 8 meters per second. So it does make a lot of useful sense there. In this case, we're actually shaping the corner of the building, so we're not really changing the shape of the footprint a great deal. We could use it on a four-sided building as well, but this is one we've been looking at. And we can also span wings between structures or out of the building or out of the top. We're also looking at freestanding wing systems which could maybe go along the central reservation of motorways. And even Bedford Square could have one. How about that? The other things we've been looking at, I say you could retrofit this onto existing buildings. This is an overarching bow roof structure with an external structure, which we can then also incorporate for external insulation. It's just trying to multifaceted different things together. And this is a combined passive solar and aeolian roof, and using the semi-transparent roofing system to also get passive solar gains, but also reduced overheating in the sort of sun space. The other interesting thing of combining wind and solar together is a very nice complementarity. So you tend to get the wind in the winter time and the sun in the summer, and they work very well together. And the graph at the bottom shows the balance. It looks like an 8-meter roof would generate somewhere between 2,000 and 3,000 kilowatt hours a year, which is pretty reasonable. The other naturally distributed form of renewable energy is ground source energy or geothermal. In certain parts of the country you have geothermal aquifers, and Southampton has managed to tap into that and set up a district heating system, and parts of Paris are actually heated in a similar way. These shows the sites where there's potential for geothermal aquifer if you can afford the drilling costs. But earth tubes, earth pipes, however you want to call them, is another approach which people have also discussed today, and that seems to be quite a good way to go, provided you can avoid any risk of condensation forming inside the pipes. But it certainly is a way of moderating the building. Ground source heat pumps are certainly a very interesting technology. These are tapping temperatures of just below the ground surface. By using the same technology as the refrigerator, we can actually get very useful heat or cooling in the summertime. And even using current mains electricity with the current mix of generation, you can actually get lower CO2 emissions compared to a gas condensing boiler. And in a study of renewable energy we did in Kent recently, ground source heat pumps was the second most important technology after wind. And there's also a maintenance issue, because when was the last time you had your fridge serviced? The types of ground collectors are quite numerous, but basically it's horizontal or vertical. Horizontal can be dug with a JCB trench. It does mean you have to use more of your ground area, so it's more difficult to use for anything else. A borehole is much more compact. At the moment it tends to be quite an expensive operation because not many are being done. But if you can get a group being done at once, then the costs can come down. And people are also looking at how you can combine those into the piles of buildings. Biofuels are the other important renewable energy resource on land. They're much more problematic and they're much more difficult. And it's not just a question of specifying a piece of equipment. You also have to think about source of supply and the quality of that fuel. But there are certain situations in buildings. Obviously there's the sewage which has to be dealt with, and with various waste systems, food waste and other biological waste can actually be converted into useful energy, and surprisingly that could be quite substantial. A lot of the stuff which goes to landfill currently could be done in a controlled environment. Liquid fuels and gaseous fuels tend to be the most useful. Okay. But wood fuels have had the most interest up until now, for historical reasons primarily, and there are quite a wide range of wood fuel boilers available which can run on wood chips or wood pellets. Again, they have to be concerned about the quality issues of doing this, and also the low energy density of these materials means you can only sensibly use it from local sources, although at the moment the problem with pellets is a lot of them are actually imported, so you have sustainable issues there, although pellets are much easier to manage than chips. Gaseous fuels, mainly two types. There's the biogas and producer gas. Biogas is produced by same process as the septic tank, and it produces methane, and methane digesters have been looked at for a long time. But if you go up to the scale of a community scale digester have in Denmark, you can start to make use of animal manures, sewage and municipal waste, and it can be programmed into a basically you can make use of community scale digesters instead of landfill, and in Denmark they have a whole network of community digesters so that farmers take their manure to the digester, and then they take it away after it's been processed as a clean manure. The T206 is the sustainable energy course. Now, it originally started off as a renewable energy course at the Open University, which some people may have made use of, which we developed in the 1990s. And it's gradually progressed and then had the next generation. Now it's been expanded to cover sustainable energy, so it's also looking at energy efficiency and new energy technologies as well as renewable energy. And I have some leaflets about that. But basically it's a course run by the Open University as a part of its undergraduate program, and there are 3 main books, including this one on renewable energy, and this is also a batch of videos and computer software, and this is where you can get it from. The Open University website is www.open.ac.uk, and currently we have about 300 students a year taking the course. So, okay.
Thank you.
Okay. There's some leaflets. Oh, I also should just mention a little leaflet. Nuclear power is being floated on as a source to global warming, and the Open University is hosting a debate next Tuesday if anybody is interested in going. I've got some information about it.
Now we're coming to the last speaker, Matt Santamoris, a physicist and associate professor in the Department of Applied Physics at the University of Athens, and visiting professor in many places. Probably I would not be able to list them all. I would venture that he probably has the largest research team in Europe in the field of built environment research. Maybe he will prove me wrong. And also very productive team with lots of publications. We have several of them in our library. I'm trying to be very good to him because he's also the organizer of a conference on Santorini in May. I'm sure he'll mention it. And of course, both myself and my students would like to attend. Matt Santamori.
Thank you so much. I'm not an architect, I'm a very simple physicist, so I will try just to report what's happened actually, especially in Southern Europe, regarding construction and energy and environmental quality of buildings. Thank you. We know quite well that construction is one of the most important economic sectors. The annual output of the construction sector is something close to $3,000 billion per year. And this is almost 1/10 of the global economy. And actually construction represents more than 50% of the investments and employs more than 111 million of employees, which is almost 7% of the total employment, and almost 30% of the global industrial employment. Now we have to consider that every job in the construction sector generates almost 2 new jobs in the global economy. So it is simple to say and fair to say that construction is responsible for almost 20% of the global employment. At the same time, almost 1/6 of the world resources are consumed by buildings. Buildings use almost 40% of the world's energy, 16% of the world's fresh water, 25% of the forest timber, and are responsible for almost 70% of sulfur oxide and 50% of the CO2 emissions. Actually, in Europe, buildings consume more than 40% of the energy. And although we have a very, let's say, stable consumption in northern countries, or there is a trend to decrease it, the energy consumption in southern countries increases continuously. And there are several reasons to explain that. If you try to plot the increase of the energy consumption in the various European countries, you will see that there is a trend to increase the energy consumption considerably in the south, and there is a trend to decrease it in the north. And if you try to see forecasts for the future energy consumption in Europe, you will realize that we expect a boom of the energy consumption for all the southern countries, Greece, Italy, Spain, Portugal. Unfortunately, this is far off or out of the, let's say, Kyoto engagements we have. So which is the reason that the energy really is continuously increasing in almost all southern countries, although the energy consumption in northern countries is decreasing? There are several reasons. First of all, we have a continuous increase of living standards in the south, and this has a tremendous impact on the energy consumption, and I will explain you why. Second, we have a huge penetration of air conditioning. Third, unfortunately, we don't have sufficient energy legislation. And finally, there is a lack of awareness and low energy prices. Let's take one by one the various reasons just mentioned and try to investigate the role of each one. During the very last years, there is a continuous increase of the gross domestic product in almost all southern countries. And we know quite well that this has a tremendous impact on the space, let's say, occupied by different persons. Just to mention that in the United States, between the 50s and the 90s, the floor requirements per person has been almost double. Or to give you some more information about the situation actually in Europe, in Moscow, they occupy something close to 12 square meters per person, while in Zurich there is something close to 51. You understand quite well that we don't need the same, let's say, amount of energy to heat or cool 12 square meters or 50 square meters. To give you some numbers, in Greece, in the 90s, we occupied something close to 35 square meters per person, and now we are very close to 45. So this is one of the main reasons of the increase of the energy consumption. If you plot the number of persons per household in most southern countries, you will see that it decreases continuously, but it is far away from the northern standard, and this is Denmark, this is Greece. So we have to expect, let's say, a further increase of the energy consumption because of the space we use. A recent study performed by University of Athens in more than 2,000 families in Athens has shown that there is almost, let's say, a linear relation between the income of families and the energy spent. And this because there is an almost linear relation between the family income and the occupied space. The richer the family, the more space they use, and the more energy they spend. So this, let's say, social and economic reason is really the main reason for the tremendous increase of the energy consumption in the south. The second important, let's say, reason, it has to do with the huge penetration of air conditioning. It is true that the impact of air conditioning on the electricity demand is really a very serious problem for most of the country, because air conditioning obliges utilities to build additional power plants because of the peak electricity problems, and this is a very serious problem. For example, in the States, almost 38% of the non-coincident peak load is coming from air conditioning. This means that you should have almost 40% of your power plants to operate for just 10 days per year. If you plot the peak demand of electricity in the various southern countries, with the exception of France, that's a nuclear country, and has a completely different profile, you will see that there is a tremendous increase of the peak electricity demand, especially during summer. Just to tell you that in the 90s, at the end of the 90s, the peak demand of, or the peak installed power of electricity in Greece was something close to 5.5 gigawatts, and last year we had 11. And this is because of air conditioning. This means that we use almost 40 to 50% of our power plants just for no more than 100 hours per year. And this increases tremendously the cost of the electricity production. And because of the electricity, of the market liberalization on the electricity sector, there is a serious problem which of the power plants will operate during the peak period or not. I mean the private power plants or the public power plants. And who is going to invest on a market that only 100 hours or 200 hours the power plants will operate? And the forecast, and these are the official forecasts from the European Commission, shows a tremendous problems in most of the European, Southern European, let's say, countries. And just to remind you what's happened last year in Italy, where for several days there was lack of electricity, especially in the northern part of the country. So the air conditioning creates a huge problem of peak demand, huge investments, and the problem we face is, do we have really to build additional power plant, or do we have to, let's say, build better buildings? If you try to see the real numbers and the absolute numbers regarding the penetration of air conditioning in the south, we have a huge increase. For example, in Greece, for a period of 4 years, we had an increase of about 800%. And if you plot the annual sales of air conditioning, for example, in Italy, you will see that there's a tremendous increase every year, or the same in Greece, and the same in Spain as well. So, and this happened when only a very small part of buildings is equipped with, let's say, air conditioning. The, let's say, expected sales in Italy or in the other countries shows that if we continue business as usual, we will face a tremendous problem in the future. Now, what does it mean on the energy sector, the use of air conditioning? Just compare the energy spent, not the peak demand, which is the major problem, but the energy spent and the energy consumption in the south, and not only in the south, but in most of the countries, because of the use of air conditioning. There's a tremendous increase of the energy consumption because of the increased penetration of air conditioning. And this has a tremendous impact on CO2 production. We have signed the Kyoto Agreement, it is enforced, and actually air conditioning is the main reason to increase the CO2 production in Europe. And you may see the numbers, what really we produced in the 90s, and which is the official forecast for the future. So fighting against air conditioning is one of the major priorities in, I think, in all countries, not only in the south. The third reason for this important increase of, let's say, the energy consumption is because of the non-adequate thermal codes and standard and thermal legislation. This is the mean U value we had actually in Europe. And if you translate this to energy consumption, you will realize that a building in Greece needs almost double of energy for heating than a building in Denmark. And this is the reality. What happens actually in Europe is that in the south, we spend much more heating, much more energy for heating, almost the double energy for heating than a building in the north, while, let's say, in the north, they spend almost twice the energy we spend for cooling. And this is the reality, and this shows how buildings are not really designed appropriately and how things are not taken into account. I tried really to explain you with just some of figures and numbers what's happened actually in the south. And there is a big discussion during the very last years because we have a serious energy problem, and sometimes we have a serious environmental problem as well. And the new directive came. I'm sure you are aware of the new European directive on the energy performance of buildings, that it is already in force and has to be applied mandatorily by the 4th of January of 2006. And we have new regulations, we have new standards. The new standards we have to apply are almost 1,003 pages. So we have to learn and apply these standards. And these standards and the new situation tries to rationalize, what's happened actually in Europe. And at the same time, all of us, we try to absorb, but on the other side, we have some experience, and we'd like really to combine all this. So I will try just to explain you what this new directive is asking for. And the new directive is intervening to the design process of the building and to the operation of the building. And I put them, let's say, together. So the new directive is asking for minimum requirements for the energy performance. Every member state has to define minimum requirements for the energy performance. Also, every member state has to prepare a calculation methodology. Now it is agreed that there will be a common calculation methodology for all member states, the one prepared by SEN. Third, it has to include a CO2 emission indicator. Fourth, has to take into account indoor climatic conditions. Indoor environmental quality is an issue now, and designers, they have to prove that they satisfy indoor pollution levels, thermal and visual comfort, etc., etc. At the same time, the directive is asking for consideration of decentralized energy supply systems based on renewable energy sources and combined heat and power. And finally, the directive is asking for a consideration of, let's say, advanced heat pumps. Now, as it concerns the operation of the building, the new directive makes mandatory the inspection of the boilers and air conditioning, but also it asks for a certification of public buildings. And this is a mandatory certification of public buildings. And also, it asks for an energy certificate when a building is sold or rented, and also when it is renovated. And this is what we should have in our buildings from next year. And this is mandatory for all buildings with a surface higher than 1,000 square meters. And this is the certificate which is proposed. Now, please allow me, I know that this kind of, let's say, information is not very familiar. You're not familiar to this kind of information, but I think that you have to know that. And let's discuss a little bit about that, because it changes completely the way we perform studies for buildings. The Commission of SEN, or in general the whole system, is asking now for a certificate. And there are two types of certificates. The so-called asset certificate, which is based on calculations, and the so-called operational certificate, which is based on real measurements. Every country has to decide either they like to have an asset rating or an operational or both of them. Of course, this affects tremendously the whole market of the building sector, the whole market of buildings. It is sure that the operational rating, the operational certification, I mean, the certification based on measurements cannot be applied for new buildings. But for existing buildings, which are ready or sold, the way the building is managed will change the operational rating. So you may have a very big F in your building, although the design is excellent, but the user was very bad. At the same time, when the certificate is displayed in an existing building, the operational rating is a measure of the quality of the management. So for a public building, the rating, the certificate, it shows the combined impact of the design and of the management of the building. And there are a lot of, let's say, advantages and disadvantages that affect the market and affect the design and affect the value the final value of the building. To face the real problem I just described you before in the south, during the very last years, we have collected data for more than 6,000 buildings in Greece, and we have established a complete database and knowledge of the characteristics of the building stock. And you may see this is a cumulative frequency distribution of the heating and the total energy consumption. In schools, we have the same for residences, different type of residences, offices, recreational buildings, hotels, hospitals, etc., etc. And these may help to understand where, let's say, our building stock is. And this shows, for example, that 50% of the building stock consumes less than 60 kilowatt-hours per square meter. Based on the information collected through these audits, we have defined, let's say, the well-known in UK performance of the typical, the best practice, and the passive buildings. And these correspond, let's say, to the 50% of the building stock, to 25%, the best 25, and this is the 5% of the building stock. And if you are familiar with numbers, you will realize that the actual energy consumption of the typical building in Greece, and this is for heating and this is electricity, is so high that it's almost, let's say, twice the energy consumption of the typical building in Stockholm, for example. But it's very important to have all this knowledge, because then you may define your own policy. Based on this information in the database, we have established a kind of, let's say, certification, and this is a certification for apartments with 5 classes. And you may see, for example, the big difference, or the difference between insulated and non-insulated apartments and so on. So this is a very good tool for governments if they like to improve the building stock, because they know, for example, that the building stock is found somewhere here or here, and they may decrease, let's say, the thresholds to achieve a much better quality. This is an excellent tool to the administrators to improve the quality. And this is the certification on the rating for air conditioning offices. This is a typical building. This is, let's say, the best practice building. This is the passive building. This is the actual situation, and not the proposed, let's say, threshold for certification. The threshold for certification has to be defined as a function of, let's say, the national goals. And this is the certification for hotels. These new standards we have been implemented together with the whole database and let's say, the certification techniques, and at the same time the calculation techniques proposed by CEN in a computer tool that allows to calculate the actual consumption of every type of building. This is for office building, for example, in a simple way, to normalize it as it concerns heating and cooling. This is the typical, the best practice, the passive, and also to have the cumulative frequency distribution and know where is the building, where the building is. But what is more important, and this is for school and residential, what is more important is that the new standards of CEN have been implemented on this, and it is possible to calculate the energy consumption and get the certificate, and at the same time design some energy improvements which are based on the calculation on let's say, official calculations coming from the CEN standard. I like to conclude by saying that actually in Southern Europe we have a very high energy consumption for heating and for air conditioning, and air conditioning is a major problem actually, and there are several techniques to face it, and we could discuss on this the whole day. Actually what we are doing in the south is that we built additional power plants, and this is not, of course, the solution, because the real solution is to build better buildings. Just to understand, the energy consumption of a glazed building in Greece is, for cooling, is something close to 400 kilowatt-hours per square meter per year. The energy consumption for cooling of a normal office is something close to 50 or 60, and the energy consumption of a well-designed climatic building for cooling is 5. So if you compare the 400 against the 5, there's a huge difference. So we have the possibility to design much better buildings, and instead of building additional power plant, the overall effort has to be on the design of better buildings. We believe that certification and rating and the whole, let's say, set of standards introduced by SEN will help to have a better environmental quality and reduce a little bit the energy consumption. Thank you.
Thank you, Matt. Well, basically now, I think it's time that we should open to questions and discussion. There are many ways of doing this. One is for people to ask questions, or I was thinking of inviting some of the speakers here to face, so that we are in a more interactive, let's say, situation. So would some of you be interested to come around the table? Maybe some people who are with their backs to the audience should come around the table, and those who are sitting that side can see the audience. Come on. And then in the meantime, lights? Lights up, please. Windows open. All these microphones are alive. There's roving microphones. And before everyone disappears, then I would like to invite people to make comments or ask questions. Klaus, you want to reiterate your... We're now well positioned. All we need is...
There must be lots of questions, Bill. We've been talking at them all day, you know. No chance.
Simmers, okay, thank you very much. Probably if I just reiterate the question I said before lunchtime and just add a little bit to it. Just the point that I purposely raised on looking for the show of hands about students that were non-AAEE course members, meaning environment and energy. I'm talking really about the non-converted people in this subject, how many were present, and if you recall, there were 2. The reason why I mentioned that is because for me, it is a symptomatic example of what I've seen in some other schools of architecture, university that I visited. And it begs to question what I call is the academic curriculum in the general architectural course. Has that got something to do that why less architectural students are exposed to the environment and energy issues or sustainability, whatever you may wish to call it? Because there is a lot of talk being said, we as architects, I will not say whether right or wrong, have the key in our hands to unlock this global problem and all these issues. But we certainly have a role to play, a prominent role to play, in resolving some of the environmental problems we have. And in so doing, the one thing certainly which we can do is for the next generation to give them the right footing for them to make the real change. I think we can only be catalysts in this process, in our, if I may say, in our joint age group, for the next generation to really engage in the big change. And to do that, education to me is fundamental, this process. And what worries me a little bit is that I cannot see at the moment enough of that filtering through for one reason or another. And that, in a way, is not just a show field here. If I may be pretty, how should I say, I don't mean to be too aggressive at the moment, but even this afternoon, I was really looking forward under the subject architecture education to see a little bit more. We have all these wonderful speakers from different parts of the world, how they in their School of Architecture are introducing the architecture curriculum and this particular subject that we spoke about today, more so than accomplished projects, etc. So, pardon to be purposely like that, but I think for the interest of the students, everybody, that is something particular I'm interested to see, because that's where change comes from. So that's to the whole panel and to everybody, really.
Yeah, okay, thanks, Klaus. Who would like to respond to that? Alex.
Everything is live.
All microphones are live.
I think the issue you've put on the table is a very, very pertinent issue. I think the subject we've covered today is a huge subject. It's vast. I mean, it's from ecology of the whole planet to actual architecture, or even more detailed than that. I think there are many ways of going about this. And this is how these issues should be addressed to the general public and to architects and to architectural education, so let's keep it more to that part of it. The first way maybe is by telling the general public and the future architects, etc., that it's your duty to think in this way, to take the doomsday, let's say, approach, that all these issues are a geometric, let's say, progression, and what happened 20 years ago doesn't mean take another 20 years to happen in the future, etc., etc. So that's one way, and saying that it's your duty, your obligation as a free citizen of this planet, etc., etc. And all that, I think, is true. Another second way is taking an administrative approach, a punitive approach, taking a whip and saying, now look, be careful, if you don't get interested in these issues, this and this and this will be the consequences. Both as a general public, both as an architect practicing, let's say, or even as a student studying. A third way could be an economic approach of, look, you're going to benefit from this as the general public or as a user, etc. You're going to gain money, you're going to save, not gain, save money. As an architect, maybe you're going to make more money because you'll be able to offer some services which somebody else maybe can't. And even as a student, maybe to invest in the same in the future. I really think that all this is not the way to go. And I think that too often this is the way we're going. And I think that is the problem. And especially with architects who may be, and I'm saying this in a bit ironic way also, are more sensitive and of other interests also, I think this is the worst way to go. To tell them that you have to do this or you can't do without this, etc., etc. I think one must really get them excited in these issues. And the way to get them excited is not only the rationality of all this that we've been talking about. And there is a lot of rationality, a lot of common sense, a lot of logic, etc., etc. But I think it's the matter of getting them excited. And because to design, and I had the opportunity to say this a bit yesterday, you have to have constraints. You can't design without constraints. You can't perform as a student in any project without constraints. So what are these constraints? Are they only the, let's say, the so logical part of this whole issue? Can you allow a student, can you allow an architect to make up his own constraints? Because he can't do otherwise. Even if there are no constraints and he believes there are none, he will make up his own constraints. Or to show him the beauty of these constraints. And that if he has the beauty of these constraints, and the reality of these constraints, and it's not a matter of just if you're going to lose a bit more energy or if it's going to be a little warmer, a little hotter, or damn hot or whatever. It's that there is a fantastic beauty in looking at these issues and solving the problems in a creative and a wonderful way. And to make it, let's say, more sexy. It's not a matter of just being banal. I think that's what we've done up to now. And many of the first examples in the 60s and the 70s were really damn ugly. So this is, they just think that by putting on whatever, this is, let's say, climatic, ecological, whatever you want to call it, that's the wrong thing to do. That's what's put off so many people. That's what's allowed, really, the teachers not to take these issues as part of the main process of design. Some things you may not need. If you're designing a hospital, you need a specialist, and maybe you don't know enough about it. But these issues, they're there always and ever. And that's, I think, making the beauty out of it, which could really help.
Okay, thank you, Alex. Owen.
I'd like to strongly agree with Oleg Tombatsis. I think he's put his finger on some of the core points. I think there was a misconception in your question. You said, what are we doing in the schools of architecture to change this situation? And I talked about what we're doing. But in a way, the more a group of people who appear within schools as specialists do, the less effect it has, almost. It's a self-defeating kind of thing, because it's seen then to be the province of specialists, of eco-architects or something. And the real challenge, of course, is to transform the value system of our profession, so that when buildings are reviewed in the capital A journals, these issues are part of the discussion. And today we've been shown some buildings, again, and they're not 60s or 70s, they're buildings of today, which are disastrous, which they are hugely damaging to this cause, because they destroy any credibility that these things have. Because buildings are not about energy systems. That's one of the things that a building has to address, but it has to address many, many more issues. So that emphasis on quality, on demonstrating that sustainability is entirely compatible with an exciting and high quality architecture, that's crucial. And the value system of our profession, so that as architects, when we discuss buildings, that this is part of our normal agenda. But I must say, I also believe that the point that I mentioned and Mantas highlighted, legislation will force change. We cannot afford that half of the capital investment that our planet is making in the future is done in a profligate way. And so legislators will come and change the situation, whether or not we like it. It's whether we're going to be part of that, or whether others will command that new process, so that technologists will take over much of the building issue.
Thank you, Owen. I'd like to bring Dean Hawkes in this, because he has done some reviews which combine the environmental with the architectural in most effective ways.
I think CMOS always does this to me. I think I'd like to step back from the specific question just a little bit. I was a first-year student in 1956. Heavens, you know. And what seems to me to be very different from the situation that confronts all education in architecture now in comparison with 1956 was that in 1956 there was a kind of unified paradigm of architecture which informed all education. There was a kind of consensus. What we've seen happen in the last, well, in the last 50 years, but in the last 20 years particularly, I think, is a move towards a pluralistic position, which has, I think, quite fundamental, profound implications for the nature of education. It means that it is possible for serious teachers to become preoccupied with a particular subset of the range of possibilities of architecture. No longer do we have the unified paradigm, and which means that an issue of this kind, which we never talked about sustainability in 1956. I don't think anybody taught me about thermal insulation in my course in the 50s. So I don't know how I acquired this interest. But it does seem to me that given the complexity of the picture in architecture as a whole, there is an inherent problem in addressing something which is seen as one of the pluralistic possibilities, and actually spreading this throughout the whole range of architecture education and hence of practice. So I think there is something in that lies at the root of this problem. The other thing I'd like to say is something I've been thinking about a certain amount. Since I retired from full-time teaching in universities, I've had the opportunity to think a little bit about it. And one of the things that's happened in my academic life has been what I would call the academicisation of schools of architecture. 40 years ago, no one did research into any aspects of architecture, except perhaps for some often very good historical research. In that period of 40 years, since the mid-60s when I went to Cambridge as one of the very first PhD students, now we've seen a model of a school of architecture develop, which certainly I think is well established in the United Kingdom. I think one will find similar models with slight variations on it in other countries, where we have the core of the school, the academic core of the school, resides in the research activity. The teaching resides in the studio. And progressively, I think, the connection between the two has become remote. Today I think we've had a kind of feast, a kind of parade of research. But how much of that actually connects into the interests and preoccupations in teaching schools of architecture, even within the walls of the school? I question that. I think things are slipping through our fingers. How we get it back, I don't know the answer either. But it does seem to be that what one has to do in order to have an answer is actually to try to kind of have a diagnosis of the nature of the problem. I don't know if that helps.
But you didn't answer the point about your reviews. So don't you think that your reviews were helping in introducing people to the discourse, the environmental discourse? Don't you think your books, the environmental tradition?
Well, I mean, that's what I've tried to do throughout most of my academic life, is to connect all of these worlds. I've taught, I've researched, I've taught, I've run design studios, I've practiced, and I've tried to connect all of those together. When I've written building critiques, I've always attempted to connect all of the aspects of the issues of architecture as I see them in the one review, see what's observed. But I think it's a kind of small, quiet voice. If you look at the general nature of building critique, in fact, I don't think there is serious building criticism going on in the British journals anymore. Actually, I think the journals have become simply part of the publicity machines of certain distinguished practices. And you can't engage in objective.
I agree with this, and I can also imagine how easy that some of us feel that how easily the audience could be frightened off by being, let's say, too technical. Because if we were, they would be frightened, and if we did that, then we would feel that we're reinforcing what they already feel, which is that this was nothing else than the technical fix, you know. And therefore, well, they don't want to hear it. They're just going to go to the engineers for that. That's what I call the technical addendum. Brian wants to come into that.
Well, I just wanted to add a thing to try and respond to Klaus's point directly about why we're not engaging with a wider cross-section of architectural students, essentially. And I think one of the, picking up on, Dean was saying that staff in schools of architecture, their focus has become, well, not fragmented, but engaged in areas of specialism, perhaps. And schools generally are now, sorry, Dean also raised this issue of research. So full-time members of staff in most schools of architecture have to do both teaching and research. And they have to do administration. This is a big load. They feel under stress. It's not popular. It's hard to get people who are that motivated. But if I just describe what's happened in Nottingham, we have 20 full-time members of staff, which may seem a lot, but we have about 750 students across the school. But we have about 45 or 50 part-time members of staff. And it's the part-timers who do the teaching in the studio. It's the full-timers, they do their structured modules, give their lectures on history, theory, structures, environment, whatever. Yes, some of them, I would say maybe half, maybe 10 of them engage in the studio, but the studio essentially is run by part-timers. Now, we don't meet with the part-timers from one year to the next. And I was saying what we need to engage in as senior staff within the school is actually some CPD in relation to our part-time members of staff, because actually the interests and enthusiasms and prejudices which students pick up are picked up from the part-time staff, and they reflect the profession as a whole. And actually, as schools, we have very, very little influence over them.
Thank you, Brian. Anybody else on this point? Or shall we try to find another? Willie.
Well, just in Switzerland is a law. You have to make heat calculation if you want to have the right to build. And at the beginning, that heat demand of the building without the heat mechanic and the production of heat. And at the beginning, architects made as usually, making a house, and they asked to the engineer, put some heating, and so it works. But the limit that was asked, engineer had to go back to architects. It doesn't work like this. You have to change windows, you have to change installation and so on. And slowly it's going to work in team. Engineer and architect are working together to make the project, because if not, it's not possible, or architect is going to be sensible. But it's very difficult in schools, or it's because it's a law, they have to do it, so they do it in a way, or it's slowly go on. But I'm sure for publication, I began to work with physicists sometimes. When they make an article, it's incredible, because they have to prove, some other people make a lecture of what they're saying, and so architects, they just pictures from the nice buildings, and nobody even goes to see if it works, if people are happy, if it's not too hard, or yes. And that's a very big difference between architecture and other field of research and knowledge.
Thank you, Willie.
Yes, I think one of the problems is that this whole sustainability and energy efficient design and renewable energy is seen as being difficult, and it has been hard. But I think the thing which might help to improve that are more availability of tools which you can do more what-if things, so that people can access it more easily. And I think it's symptomatic of lots of education, because more people are going into non-science subjects in university. I think it's the same phenomenon. People perceive things they don't want to do it as being hard. So if we can get over that, I think it might help.
Okay.
I'd like to add some additional information. I think it refers to professional assignment of the architect, which should be in near future. In Japan, for instance, I feel that there is a big and deep gap between so-called designer architects and officials, governmental, and researchers, academic or industrial. And the government and officials and the researchers work together to develop, for instance, assessment system that we're talking about, some people. And architect designer ignore, they're not at all interested in because they think that it's something to do with engineer. But actually, since last couple of years, several local municipalities began to apply this assessment system as mandatory for the designers and the architect to submit. And if you want the more floor area, then you should have a better score of the assessment system. For instance, well, this is a stream, very strong, beside the architects or designer. So I feel that architects are more or less isolated, they begin to be isolated from this stream. At the same time, if you have a big project or even small project, you need to have a project manager. Who would be the project manager or facilitator of design development if you consider of the life cycle of the project, not only until design or completion of the work, but also the further operational stage and so on. And in Japan, through the recession of the economical situation, no municipality has money, so they need a private initiative, So the people who invest money in the building, they want to have some performance or quality or whatsoever. How is it the good object to invest or not? And that should be somehow evaluated. So all this aspect, is almost ignored by the architects or designers. I think it's very dangerous somehow. At the same time, as many people told them, know the place, know the people before the design, and it is so stimulating, it is so interesting. It is a privilege for us, because every time we have the different places and the different people to cope with. So I think it's so interesting work, and out of that we can develop the very interesting design, not only the boring and just put on, put the PV on the roof. This is something else. Well, I think it's a very interesting perspective for this sustainable architecture if you consider it that way. Thank you.
Okay, thank you. Now I'm just looking around the room more carefully, and there's us, and I can see some other long-term colleagues, and then essentially the people we have in this room, in the great majority, with perhaps two exceptions, maybe 2 or 3 exceptions, are either current students in our master's program in sustainable environmental design, or in fact graduates of it. And so to some extent, maybe now we're talking about those who are not here. So I was just wondering, I was trying to persuade one of the group in this room who was one of us and is also one of them now, of one of those not here, to say something, but she will not do it immediately. So then I was thinking, what can we say for those who are here, i.e. those who were bold enough to go into the financial expenditure and the time investment and the effort that we are subjecting them to, despite the fact that outside or around them, in fact, both in this school and others, the environment is so different. So how can we encourage them? How can we say something to convince them that this is worth it? And by extension...
I would like to bounce the question back.
Well,
why you chose to do this, and how you found circumstances in your school. Were you in the minority? What was the situation?
if I were them, I would say,
Sorry.
well, I don't know. I didn't want to put them on the spot. I wanted to put you on the spot first. And then they would come in, I think. But, I mean, would anyone on the panel comment on this?
Simos, this may be a very simple view, but Dean talked about his education. I think you said 56 or something, and certain things nobody thought about it at that time. And we've all been through this period of education. 25, 30 years ago, nobody thought about designing a building thinking about disabled people. Nobody thought about it, except, and then suddenly it became a topic of great interest, and it was started in Sweden, the Scandinavian countries came here and became legislation. And now I would guess that every student knows that it's important right now to design for disabled people. And nobody is producing designs for any kind of public building or any big building at all which doesn't incorporate the design for the disabled. So there was a kind of change in the way people approached it. Maybe people were saying, I can't do this because it limits my design freedom, and I don't want to do that, but they have to learn to do it. They have to do it. And I think the same thing must be now occurring for me in architectural education. It's a prime responsibility that every scheme has to think about an environmental matter of some kind. But the complexity for me also is, and this is coming back to the resources, there are so many ways to do it. You can be thinking about a glass building and doing it in many, many different ways. You can think about wind farms. You can think about burying the building. You can respond to this question in so many ways. Nikos showed us a building with underground. But nevertheless, that doesn't matter. That allows the students to come forward with their own solution. I think the message for me, I'm an optimist in this matter. I think students will now take this. They know about the global message. They know that they have to do something with their buildings. So nobody is going to start designing projects which don't have some kind of view, whatever the solution is, about this subject. That's my view.
But Garan, I'd like to, but they aren't. They're carrying on in the same way, and I'd like to be more optimistic. Broadly speaking, I'm more optimistic about what we can do, but it is a real problem. And it's because if it's not a priority for those who are setting and running a studio project, if it's not a priority for those teachers in the studio, it is not going to happen. This is why in my talk I really emphasize the importance of engaging with the design process. We're not going to do it by saying you have to do it, produce it, because in fact effectively the RIBA has done that. The RIBA criteria, the ARB criteria now, and it would apply to every school in the country, including the AA, absolutely every school. It requires that in order to be a prescribed course, i.e. an accredited course, that material is included and the students demonstrate ability, understanding, knowledge in the field of sustainability, da-dum. But we know it's not happening, and it's not happening because it's not a priority for those who are teaching in studio. And it's a problem.
You have the wrong people.
Well, yes, well, that's right, but, yes, sorry.
Cheryl.
Yeah.
I'm a graduate of the EE from 2003, and I've just been teaching at London Metropolitan since September last year. So it's an introduction at a new level, as you were saying, in terms of integrating environmental education throughout all the undergraduate years, and I think it's a fantastic interjection into the architectural education. And the way in which this school is particularly tackling it is to integrate the modules with the studio work, so that instead of these independent modules which are introducing environmental strategies being assigned their own reports and their own assessment work, it actually has to be integral with the studio work. So that means that the student can't progress with the studio work independently of other information coming at them from other directions. And I think that's a really good way to make them think about the two issues coming from two different directions, which is their studio work and studio direction, and also the other modules which are introducing other ideas. And so that's basically the way in which it's been tackled. So I don't know if that's a way in which it's been tackled in other universities around the world, but that's just one that the London Metropolitan are doing at the moment.
Okay, if I'd just come back on that comment, because there's another university which is on the other side of the world where the design studio is actually designed by the teachers of the lecture courses and then is delivered by the studio tutor. So in fact, kind of turning it around the opposite to what we find in many schools here. And it appears to be working excellently in the undergraduate years, but then falls apart in the postgraduate. But it is one option. If I may just add, a lot of the talk has been about the drivers from within education, but to offer something, I think, to the students who are graduating, if you look beyond architecture, which I often find I do, there are lots of ripples of change taking place. When you look at the changes that are going to happen and are happening to planning policy, planners getting involved, and maybe architects don't like that, but there is going to be more scope for demanding better environmental design of our buildings in order to get permission for buildings and schemes to go ahead. You'll also see, if you look through documents being produced by the City of London, that kind of the ethical investment angle has been taken a stage further. People are starting to realise that buildings could be a liability in the future, not just an asset, which they have been in the past. And just expecting the value of the building to go up forever is not going to be an answer. It's got to be managed, and it's got to be an environmental and sustainable building, and that kind of thing is not mainstream, but it's starting to happen. So I think there is a positive thing for the future there.
Anyone else from the panel or from the floor? How about some of our current... Yes, Thanos. There's a microphone there.
Well, just to share with you some thoughts of mine. Well, the one important issue is how to introduce sustainability into the curriculum, right? Well, perhaps we should think that architecture reflects society, and that means that architecture reflects the dominant social values. How can you have an architecture, a sustainable architecture, in a non-sustainable society? How can you expect to have a client asking for an energy efficient house when he buys, let's say, a big 3000 cc engine SUV for his shopping, or going for holidays in faraway countries, spending lots of kerosene on the air, or to buy more and more goods as dictated by advertisements? Now, in such a society, can we seriously expect to have a sustainable architecture? And let's assume that, yes, it is possible. Then the next step is how to have that sustainable architecture. And perhaps I should go back in time, like previous colleagues here, and remember my years at the university, which was 30 years ago, when still modernism was active and in its peak. And a few years later, there was a U-turn, and we had the introduction of postmodernism and all those variations of, let's say, the children of modernism. And just to remind you, the methods that one could use in order to direct social or society towards one or the other direction. I remember the magazine AD. I'm sure everybody here is familiar with architectural design. I was a subscriber in the 70s of the magazine. And I remember that the main subjects were things like alternative technology, social housing, let's say a kind of leftist approach to architecture. Then, about the same time when Maggie became Prime Minister, the magazine was bought by Dr. Papadakis. And right after that, there was a tremendous change of the magazine. Then the issues changed completely. There was a heavy dose of the new postmodernist stars like Michael Graves and that sort of architects. And the magazine was really something completely different than what it used to be. I believe that as you can influence society by, let's say, commercial or direct or indirect advertisements, the same manner you can have an effect on architectural values. Because we are asking how to introduce sustainability to schools. Now I ask again how postmodernism was introduced to architectural schools. It wasn't introduced by research seminars or symposiums, etc., etc. It was introduced simply by imitating what the glossy magazines of the time and glossy books were proposing as a kind of new architecture, which would fit the new political establishment. So I think in this case, in our case, it's perhaps we will be waiting in vain to introduce that kind of architecture we're talking about into schools that reflect the society that pays for those schools and where the students of those schools come from. Because we should have in mind also that what we have in our minds is not just a school product, it's also the product of influences that we have outside of the school. Right. So, do we have sustainable influences outside of our school?
Okay, thank you, Thanos. I have a comment on this because I think we come back to the previous question. So somehow, but I mean, I'm optimistic, but I'm also observing what's happening in this school, and what's happening in this school is actually at this moment very positive in many ways. The only problem is the source of inspiration, because I mean the driver here is not stylistic at all. I mean that has gone a long time ago. It's, I don't know what to call it, but it's generative. But it's looking for the inspiration of the generation outside architecture. Well then, I mean, if it is looking for it outside architecture, and we have units that run MATLAB in order to get space frames, we have units who measure temperature actually in order to get a starter. You name it. And I'm still hoping for one of the students to say something. And maybe I'm trying to intrigue them into this. And so why not then the climate? In fact, I have courses now both in general studies and technical studies with diploma students, and they all show a concern with the climate. It's just that either they think it's too technical or too trivial, and that the other method, the more abstract method, is the one that they would follow. It's just a flip of a, not even of a coin. It's a very small sort of twist that, well, it could be just the collaboration of the design staff with some people who have this kind of knowledge just in the same unit. You know, in the same way that this collaboration seems to be working in much more a specific way in this school with engineers of a structural kind. The structures are back as a generative concept. Have I said enough? Oh, thank you, Selina. Okay.
I think I'm not going to say really something new. I just can talk about my experience. I did environment and energy last year. I finished last September, and I'm back to normal, the main school. And what I observe as a general thing is like there is for me it's missing an overlap between the different programs in school, and I think the problem is that there are several problems. No, but it's time and it's organization, it's everything. But in a way, today also I came in kind of late because I had tutorials and I was busy with other stuff, and it's just how it is. You're always busy here. But I don't know, I see it more like, I like kind of, someone said it has to become kind of sexy, like all the environmental agenda, and I think that's true, and I think it's not the way to, it's not like to impose it like in a radical way. It's kind of, I see it more, for example, here in school right now there is going to be a change for next year for sure, and stuff. So I see it more kind of an overlap, perhaps not throughout the whole year, like in the programs, but more like kind of organizing workshops and then allowing these overlaps and kind of seeing into other ways of working and to see how environmental strategies can influence design and how, or generate design and vice versa. So yeah, that's kind
Thank you. Thank you, Selina. And anyone from our current group that, James?
Yeah, I can use this one here. I see it, I'm a current environment and energy student in this year's program. I see sort of the issue of a lot of overlap, or a lot of technology being added in layers on top of what I see, and the reason I came here is a way to kind of, I think Dean mentioned that sort of this architecture of imagination and creativity, where we should, I think, as students, be thinking about all of these issues as integrated into our designs, as more inspirational and more, what am I trying to say? We have the ability to see particles and to see spaces in a more abstract way, and we should then take that ability and learn some of these concepts early on, and then test some of the complexities and some of the evocative forms that we're developing with some of these concepts. We now have technology to produce some amazing shapes and configurations which are directly related to environmental issues, and can then take this whole consciousness to a higher level. But what sometimes happens is there's this understand all of the techniques of one particular shape and then try and apply that, where I think sometimes the students feel like we want to innovate, and I think we should try and talk to students about how to help our clients innovate and how to work with the industries and the manufacturers to innovate. So,
thank you, James.
Yeah, maybe I'm not here to do a comment, but I think necessity is the mother of invention. And if you really think that now the constraints are here, and we had Alexander talking about the beauty of constraints, I think it gives you great possibility, a great opportunity to do a real individual design for a special site, and not just to be in trend with trends which are all over the world. We have all over the world the same malls, and we have the same hotels, and we have the same curtains, and we have the same chairs and the same products, which I see in Tokyo, and I see them in Beijing and in Shanghai. And I think it's kind of boring to see those products all over the world, and it's missing the diversity which we have. And if we have so much diversity all over the world, I think we as architects or as designers, we should approach on those points, to those points.
Thank you. Microphone.
I had a question regarding something Dr. Thanos said. He said, I can't imagine China and India having standards of living similar to California and the world being safe at the same time. And coming from India, I can tell you it's already happening. And ceiling fans are already being replaced by air conditioners. And I was wondering if any of this panel is involved with the developing world. Are you trying to involve it in your symposium? Are you trying to meet with people who have such similar education in that country?
Absolutely. And that's the subject of our symposium on April the 5th. It's a profound question, and we should be engaged with other institutions in India and Southeast Asia and China. And this isn't on, is it? But just click it closer. Hello? Yes, there we are. And there we see actually I'm more optimistic through the contacts I've had both in India and China, in that there's a huge I think there is a huge will to change and to engage with these issues, enormous, and it's embraced through the curriculum and in the universities. So somehow I think old Europe is finding it hard to change, but there is radical change in Asia.
I would just like to add something to what I said.
It's on.
It's on, okay. I actually have a lot of sympathy and agree with him. I've had the lucky fortune 2 years ago to be invited to Peru, where they were setting up a brand new school of architecture. And there was a big debate similar to this, and it was over 2 weeks. What direction should that school take? And they invited people from South America, the USA, Spain, they came from Japan, Italy, Switzerland, England, all sorts of different heads of schools of architecture were there to discuss the subject. Without going into any details, all I found in the conclusion was that the heads of the schools, I'll leave them anonymous, from Italy, Switzerland, and that were very reluctant in changing the tack in terms of embracing more the issue of sustainability. The Spanish, Portuguese, and the Latin American countries were very much in favor and had already started changing their curriculum. Maybe it is because they realized the problem they're going to be faced with, because they don't have the economic power and everything else. I don't know. That's why I didn't want to say this at the beginning, but it's nice you brought it up, because that is why I was interested in the curriculum. We had long, big debates. And because they were worried that the whole focus on sustainability was actually diluting the essence of the original education of architecture, historical, classical architecture. So the very interesting debate going on. But for me, that gives me a little bit of hope that at least they are embracing it, and I think we should do really more, because we have more the capabilities and tools and some experience in the processes to help them. But I actually agree with you.
Thank you. A question comes that, as you know, we discussed that this symposium co-organized with the International Union of Architects. We're hoping perhaps there will be something to take to the UIA conference in Istanbul in a couple of months. What is the message? I mean, I would like to bring the UIA representatives here in the sense that but I mean, I'll make my question very specific. What hold do you think that the UIA has on architects, on how they practice and how they're educated, and whether one can put something in there to have an influence?
I remember your anxious question some months ago when I asked you to organize this symposium, and you were asking me, what will be the benefit of this? What we have to wait? Why to do this? And after the question that your colleague asked, why not so many students here to follow this symposium, I would say that I am much more optimistic than I was before this meeting. And I would say why. You know how many few people are protesting against the nuclear? Very few people are protested against. And nuclear is the fear of our future. I think that still for this sustainability there is much less people protesting against the energy consumption and what is that. So do not worry. It is the romantic. The romantism. The romantism was a revolutionary movement. It's not what we see in the paintings. Romantism was a revolutionary movement against the capitalism before the French Revolution, if you remember. So I feel that we are in this romantic stage. I like very much that there are so many people with so many knowledge that are discussing between them how to educate architects in order to be more informed about the word sustainability, which is a word, I don't know if it's very right, it's a little bit banal as word. Everybody says about sustainability, nobody understand what is this. And it is very simple. We are monkeys. So if we could live as the monkeys, this is sustainability. And during 1,000 years ago, there was very good sewage systems. Here we don't. Now we don't have. There was very good watering systems. I was telling that we were collecting very easily the water. Here we need a lot of consumption of energy for collecting the water. There was very easy methods to protect ourselves from the sun and from the wind. Today, we don't care about that. So if we go back, so we should be a little bit romantic. Concerning education, I feel that this panel of professors and specialists, even if it was only, if we were only between us and discussing the way to pass the education to the people, it's already a very good step. It's very good. I think it's very, very important. Then what is the aim of what was my aim as, let's say, responsible for trying to disseminate the renewable sources in the context of the UIA? You see, UIA has a big tool, a big advantage, the dissemination of the information. So what we did today will be disseminated. That's true. Will be published in the newsletters of UIA. It will be announced. Everybody will hear that something happened in AA, and everybody will understand that there is a lot of awareness about what is this sustainability. And this will pass in the next coming Congress, which is in Istanbul, and Istanbul is a city, is a town with one of the highest consumption of energy. And the Turks are very worried about that. So I believe that through the dissemination of these meetings, not only this, the meetings that we did, the meetings that we are going to do, even if there are few students, the students will hear. But more or less, they have to hear about these meetings, the professors. It's up to them, as Thanos said and mentioned, that there are not too many professors that are passing this, let's say, these sentiments of awareness against consumption of energy to the students. And there are a lot of specialists. Of course, once you have the client, or once the architect needs to have a client, and the question of the client is how it costs me the sustainability, 5%, 10% of the cost of the building. This question is common. So why the architect, a new architect coming in the market to apply this methodology? But the matter is not that. The matter is the dissemination of the information that this is not a costly thinking, but exactly is the contrary. So do not worry if there is no many people here. The dissemination of these results will be done, and is already done, and will follow. And I think this is the role of the UIA. The role of the UIA is exactly to find methodologies in order to pass to the architects of the world different, very important messages. And this is not a big message, it's only an SMS message.
Okay, thank you. Thank you, Nikos. While you were speaking, I did some numerical calculations. They were prompted by the reminder there from Dean Hawkes that he started studying in 1956. I did a very quick calculation, and I worked out that collectively, as a panel, we have 500,000 of experience, not just in architecture, because that would well exceed, but in environmental research. So if you wanted to show the UIA how wise we were, maybe you should quote that. But on the other hand, it also shows how old we all are. So I want more young people to say something. I thought Amy there, down there was not any longer. Please.
Hello. Okay, well, I kind of have two, it's kind of a comment and a thought or a question, and they might kind of oppose each other while they go hand in hand. And one has to do with why I came here, and the other is perhaps why why students and how we get students and more practitioners interested in this. And on the second one, I think Selena's right. I think there may be a certain amount of sex appeal that has to go along with some of this with the environmental architecture to get the students into this room. I think that's the very thin facade of what we need to do. But at a certain point, we have to get them in the room, and we have to keep them excited and keep them in the room, because they come in and they might see a chart on the wall and they're like, oh, what's the architecture here? And they leave the room. And so there's got to be a way that how do we make them interested in what we're here talking about? And for me, when I went to architecture school in the States. We're not all so bad in the States. Did my undergrad there, and in most studios, you didn't talk much about environmental issues, and if you did, it was probably brought about by a certain tutor and certain interests of the tutor, or a certain student, at which point the environmental issues became a very, romantic thing that they presented in their projects that they didn't necessarily know very much about, but they could show it in a very romantic way, and architects can all speak architecture speak and make it sound great. And so some people, it became interesting to some people, and I had the opportunity to work in the middle of nowhere in the U.S. and do a design build project where I actually got to work through some of these things and the social issues and the environmental issues of what the architecture could be. And that maybe, for better or for worse, gave me a very idealistic view of architecture and the environment and the social issues that surrounded it. So I went to practice, ready to start working in a firm, went to work for a pretty big, well-known firm and thinking, okay, we're going to get a chance to do these things because that's what they told me in my interview and said that I would. And I found that very little was understood by anybody there about environmental issues. And these are people that have been practicing for a very, very long time. And they come to me and they say, oh, we've got this proposal to do somewhere. Do you have some kind of environmental hot word that we can put in this proposal? And I don't even know. And so telling them, how do we go about those things? And very little of these practitioners actually understand these things as well. And you're working on projects where you've got a stone coming from Italy, going to be milled in Portugal, going to California to be installed, and that's just how all the projects were working. And I don't know where I'm going, but so people just okay. I think think that there's a certain lack of understanding, and so it took, working there for 3 years and, working on some very well-known projects and I found that I was forgetting where I came from and what I wanted to do when I started working and what I had gotten from the rural studio and the opportunities I had there. And how do I, revisit those things? And that's why I came here, is I dropped practice. I'm gonna come learn these things, and it took me that initiative and somebody in my undergraduate really pushing those things upon me, but not in a very gentle way, just making it very interesting and it not just being hot words that we were presenting in our projects. It became what we were doing, and that's kind of what I have to say.
Well, why don't you chair the next symposium, I think. So, well, it's 6 o'clock. I mean, we can either... Bob.
You wouldn't believe she's one of the youngest.
It should be on, Bob. No, it's not. Hold on.
Bob can hold the turning on that phone.
No.
I'll shout. Right. Now, Brian has said what we need is dynamic studio teachers to enliven the students. Now, I'm not an architect. I'm a computer programmer. And years ago, I read Edward Masria's lovely book on passive solar architecture. I thought, what a wonderful book, beautifully written. It inspires me. Do we need more inspiring teaching material? How are students inspired? Are they inspired by the teachers, or the materials, or by actual projects that you can go and see and be inspired? Can I put that to the panel?
I would agree, Bob, very much with what you've just said. I think we can blame many, many people, and maybe because I have nothing to do with teaching, it's easy to speak and much more difficult to do. But I think that a teacher, like even from kindergarten, and right up to much older students or pupils or whatever, I think that the inspiration value of the teacher is of utmost importance. I remember, and it's irrelevant, but I remember I hated chemistry when I was at school, to the day that I really got a good teacher. And I said, well, there's something there to it. The same for classical studies in Athens. I hated them. Till the day that I changed school and I had a real good teacher. I think structure was mentioned once or twice here. You can get lessons of structure and static and all that, and it can be damn boring if all you have to do is to learn the calculations and not the... I'm talking as an architect. I'm not an engineer. It's different. But as an architect, what you're wanting to have is the inspiration in what structure means to architecture. And that's what you need in environmental issues, in all these issues. So there has to be inspirational teaching too. There has to be methodology, and there has to be many, many things. But inspirational teaching can change the daylight out of a student. And I think it's very important what you said.
Can I add? I don't need the microphone. A word that's been used 3 or 4 times in this discussion, and I think it relates directly to this question, is romance. People have been talking about romance. And I mentioned in my talk this morning Leslie Martin and his definition of the word architecture. One of the things that Leslie did for me shortly after I arrived in Cambridge was give me an essay to read by Alfred North Whitehead, the English positivist that they go to. It was called On Education. And Leslie said, read this, I think it will inform the rest of your life, or something like that. And Alfred North Whitehead characterized the process of education, whatever the subject, as having 3 distinct phases. The first is romance, that very word. And I think you're absolutely right. If we're going to make this subject engaging to a wider student constituency, we have to see it in terms of romance. To some extent, that's what I was trying to say in my contribution this morning. The second phase, though, and it seems to me, I tried to test this model out empirically in my teaching life. The second phase is the phase of precision. And I think we've had much about precision here today. Romance is fine, but romance on its own isn't enough. But if you're convinced by the romance, then Whitehead's proposition is, and I think it's been borne out in my experience of teaching year after year after year to architecture students, is that you will then be willing to submit yourself to the hard work of the phase of precision. You understand things, you get behind the appearances, the abstractions of physics and mathematics applied to the stuff. And then Whitehead's third phase is the phase of generalization, when you don't take precision absolutely to the issue of making architecture or whatever it is that you're feeling interested in. You have actually to be able to kind of subsume that precision into a more generalized understanding of all of the issues that are at stake. And then you can actually begin to deliver. And I just offer it to you for something to think about. You know, romance, precision, generalization. In the Cambridge School, when I was teaching there, we organized all of the technology teaching on that model. Each year had that model. The overall course, the first 3 years had the model. The first year was a random year. The second year was a precise year. You did your number of questions. The third year, you connected all of that back into the design studio. And that was a model that sustained it, as I've used the word sustained, the Cambridge School for many years, and to some extent still does in its teaching. I think there's a kind of legacy. From time to time, what happens, of course, is that you, in any field of activity, the thing becomes kind of diluted, it becomes diffused. The entropy of your system increases. And from time to time, I think you really do have, as it were, to get the metaphorical Bunsen burner out, to get the molecules close together again in time as well. And that's something, again, I think good teachers actually do observe. And we have come through, having had a relatively long life in this business, I have seen these phases kind of go. And we may be at a time of fairly high entropy in the system at the moment. I don't know what the catalyst will be to bring it all together again in time as well. But it certainly seems to me that if we characterize the issues of sustainability in a serious way as romantic, then I think we might be on. We might have a challenge.
Well, I think it will be very difficult to find better closing words. And therefore, on behalf of the AA School, both that part of it which is here and that which is not, I would like to thank you all very much for coming and sharing with us today. Thank you.
Stop on your head. Romantic panic, yes.
Yeah.
Oh, yeah.
So we have a
Thank you. I like Portugal. I like Portugal. Sorry?